So, hello everyone, good morning. So, today we are going to discuss photoelectric effect, and this effect was explained by Albert Einstein, and he got Nobel Prize for this for explaining this phenomenon. So, this is a very important topic. You will find this topic in both physics and chemistry, and this is very easy. So, before explaining this photoelectric effect, we have to know something about light. What is light? So as we know that light shows both wave and particle like nature, but to explain photoelectric effect we have to consider only the behavior, that is particle nature of light. So suppose light is coming from a source or from somewhere. So when light travels through medium or in vacuum, light, it brings or it transfer energy, and the energy is consist of photons, or we can say that light consists of photons. And what is photons? There are some packets of energy. Suppose these are some packets of energy, and these packets of smallest packets of energy is called photon. All right, smallest packets of energy, these are called photon, and light is composed of photon. All right, so what is light? It is formed by photons, smallest energy, or teeny particle or teeny packets of energy is called photon. These are packets of energy, and it is the smallest part of light. Okay, we'll consider that light is particle. And after that, one scientist, Mr. Max Planck, he gave an equation to determine the energy of this photon. And according to Max Planck, the energy of photon, that is E, he gave this equation, Mr. Max Planck. According to him, E is equal to h nu, where h is Planck's constant. Planck's constant, okay, and its value is 6.626 into 10 to the power 34 joule second. Okay, and nu is frequency of light frequency. Okay, all right. So after this, see, so after this we'll come to photoelectric effect. So what is photoelectric effect? So say for example, there is a metallic plate. Say this is a metal of cesium. Okay, so in this metallic plate there are so many free electrons in its surface, but these free electrons are not free to move about, because these free electrons are continuously, they are attracted to the nucleus of so many atoms present in this metal sheet, so they cannot get removed from this metal without getting some energy from outside. Okay, and Mr. or the scientist J.J. Thomson, during his experiment, he observed that when certain light with certain frequency are allowed to incident on this metallic plate, the free electrons get separated, or they are removed from this, or they are ejected from this metallic sheet. These electrons just get removed. Okay, sorry. So this is simply the photoelectric effect. But Here, what is the most important thing is an equation which is called photoelectric equation. So before coming to that equation, we'll have to know few terms related to this. Number one is threshold frequency. Threshold frequency. Frequency, which is denoted by nu. So threshold frequency, again we'll consider this a metallic plate or metallic sheet, very thin, very light. Okay, free electrons are there. So to remove free electrons, we need to incident light on it. Okay, but the light must have a minimum frequency so that these electrons can be ejected from the metal surface. And if the frequency of that light is below that required amount of frequency, then after even incident any light, the electrons will not be ejected from the metal surface. Okay, say for example, there is a box in a table. If you want to push it, you have to apply force, a minimum required amount of force. But if you apply force which is below than the required amount, then you cannot push it forward. Okay, so that's why the minimum frequency, which is actually the property of this metal, actually different for different metal, the threshold frequency is different. Remember that this is the property of metal. So there is a minimum frequency requirement for which electron can be ejected. Okay, so this is the threshold frequency. After that we'll see number two terms, work function, work function. And this is also the property of metal. Say this is a frequency is different thing and energy is different thing. Okay, here to remove one electron, okay, the amount of energy which will be required to remove one electron from the metallic surface will be called as work function. This is denoted by phi. Okay, or we can also okay, this is phi naught, sorry, threshold frequency is denoted by phi naught and work function is denoted by phi. And work function we can write phi is the, we know that it is the minimum energy required to eject one electron from the metal surface, and phi is equal to, energy is h nu, so here it will be h nu naught, because nu naught is the minimum frequency of light which will be required to eject one electron from the metal surface. Okay, so after that, see, the main funda will be started now. Again we will consider this metal surface. There are electrons. When we will allow to incident sufficient or required amount of frequency having light to fall on this metal, okay, what will happen? The energy or the entire energy of one photon will be transferred to one electron. Okay, this is the, say for example, this is photon, this is electron, one electron. So when we will strike this metal with the proper or required amount of the proper selective light, the entire photon, the entire energy of photon will be transferred to this electron. Okay, and after that what will happen? One part of this is E is the total energy. It is the energy of photon, which is equal to, we know that, h nu. Okay, this is the entire energy of one photon. So when this entire energy will be transferred into an electron, one part of the energy will be utilized by this electron to get itself to get removed from this metal surface. So you need to electron need a minimum amount of energy to get removed from this metal surface, which is called work function. So one part of this entire energy will be utilized as work function, so this is phi, and the remaining part of the energy will be utilized by this electron to get it a to give it a kinetic energy. Okay, kinetic energy. We know that E is h nu, phi is h nu naught, k is kinetic energy, and which is written as half into m is the mass of electron, and u is square. So if electron has a kinetic energy, that means it will definitely have a velocity. Now if we try to rearrange this, if we put this term here, this is, we can write half into mb m u square, then we put it here, again we will bring this here, taking common h we'll find this. Okay, and we can write half into me u square as kinetic energy. Okay, the main formula is this is the main formula. Okay, and these are the rearranged formula. This is also correct, this is also correct. Okay, you will get numericals based on all these formulas. And the last thing that is that if you want to calculate this K, there is a kinetic energy, how can you calculate this? See, let me explain. See, I have drawn one circuit. After incidenting this light, electron will be ejected from this. Electron will get a kinetic energy, and if we connect this, arrange this thing in the form of a circuit, and if we put one positive potential here. See, these are electrons are attracted to positive side of battery, so this will be attracted to this, electron will be come to this. Okay, so now if we want to calculate the kinetic energy of that of electrons, or the maximum kinetic energy equaled by one electron, we have to see that we have to apply negative potential. Okay, here I mean it will be then negative, it will be positive. Then if we keep increasing the negative potential, so what will happen, at certain potential the movement of electron, or the velocity of electron will be zero at some point. Okay, suppose we are pushing something here, this is an object or electron, whatever, we are pushing it to this direction. Okay, if you want, or if we want to calculate the energy, the how much energy we are applying, then we can apply another energy in the opposite direction. Okay, at certain point it will stop, it will not move, it will stop here. Okay, so by doing this we can calculate that at this point, since this object is not moving here or there, it is stopped, that means this is the energy. So we can then say that this energy is equal to this energy. Okay, so when we will apply a negative potential here, at certain point the movement of electron will be stopped, and that potential energy, that will be the that will be the kinetic energy of electron. So kinetic energy half into m square. Okay, and this K will be equal to negative potential, this is denoted by E into V. Okay, E is charge of electron, V is the potential you will apply, okay, at which the electron will, that means there will be no current, that means the movement of electron will be stopped. So this is all about photoelectric effect, and there are some graphs related to this. See, one thing, very important thing is that the current that will be flowing through this circuit will be dependent on the intensity of the light, but the energy of electron will be dependent only on the frequency of light, okay. So this is a very simple thing and interesting thing, and based on this there are few graphs, but I don't want to make this video longer, so we'll try to discuss those things in next video. If I get good response from viewers on this video, we'll definitely continue. Thank you so much.